Let's talk now about listeners. If we look at getDoc or getDocs, both of these are just going to return one time. They're going to return what the state of the document or the documents is at this particular point in time. GetDocs, again, takes a query, and getDoc takes a docref. There is also the possibility of having a recurring notification. You say, I want to listen for this document ref, and I want you to call me back whenever it changes. That is on snapshot. So we can pass in to on snapshot a docref. This document reference specifies the document we're interested in, and then we also pass in a function. And this function is going to get called once, shortly after we call on snapshot, and then every time from then on whenever anything about that document changes. So if a field has been added, a field has been deleted, so on. Here we can do whatever we want to do with this doc. So again, called once. So it's not unlike getDoc when you put a .then, which also gets called once. But then it's called from then on whenever anything changes. And what's nice about it is whenever anything changes locally or when anything changes in the cloud through some perhaps remote client. And as well, there's also an on snapshot that takes a query. And again, a callback. This callback gets called with a snapshot, and it can do whatever it wants to do with that snapshot. So it might do, for instance, a snapshot.forEach. This is how you're normally going to be using Firestore, is with these recurring listener cases. You're going to set up probably a snapshot on your main collection, and then it'll just get called whenever anything changes. In fact, the way you're going to normally make changes to documents is you'll use either update doc or set doc, and then just rely on the fact that even if you make the change in your application, your snapshot listener is still going to get called. You'll probably just listen to a collection, and then to begin with, you'll get that collection of documents, and then you will go ahead and iterate through and save them and do something with them. And then if a change happens, right, if you make a change, you'll call the Firestore set doc or update doc, and that'll cause that callback to be called again. And that works really well with React. What happens here is, let's say a document gets added. The onSnapshot gets called for that collection, and then that onSnapshot gets given not just that single document, although it's possible from the snapshot to get that information, but normally it just gives you all the existing state of things in that collection. So according to the query you made, what's the existing state? And that works really well with React, where you're going to just recreate the entire tree, and then React will look and see what has actually changed and what needs to be updated in the DOM. So these you're normally calling in opposition to calling getDoc or getDocs. Let's just look at how this is implemented. So we've got, let's say, user 1 here and user 2 here. So user 1, user 2, and we got the cloud in between. Let's say user 1 makes a change to a document. They call update doc. That is going to, of course, change the data in the cloud. And assuming user 2 is listening to the collection containing this document with a query that would return it, then we're going to get this notification. And this guy's snapshot callback is going to be called. And now it'll have the new document in it. How does user 1 get notified? Well, it could be user 1 makes this change, right? We're using update doc, and the SDK then changes it in the cloud and then relies on the notification back from the cloud back to here. That is, could be how that's done. But that's not how it's done for two reasons. One, the latency. That's slow, right? User 1 doing update doc all the way back to the cloud and then all the way back down. Instead, there's an optimization where the SDK on user's 1 machine says, oh, I'm calling update doc, but I also have a listener registered for the collection this document belongs to. I'm not going to bother waiting for a notification. I'm going to just go ahead and call the listener with the updated information. And then I'm not sure whether the notification actually comes back to user 1's SDK and ignores it, or whether there's something in the SDK that it realizes it doesn't even need to call back to the listener because the change is happening on this machine. One advantage is the latency. A second advantage of that is that Firestore can also work in a disconnected mode. If you don't have a network connection, the update doc is actually going to work, and it's just going to save the information in local storage. When we next are connected to the network, it will send up any saved changes that need to go. So given that's the case, the SDK can't rely on the listener calling back from the cloud because it might not have actually been able to contact the cloud. That's another reason why it does this calling of the listeners locally without waiting for the notification from the cloud. This is the way you're normally going to be using Firestore, is with these snapshots.